Okay, check digits are part of numbers that are called identification numbers. Identification numbers are seen all around you. Some of the most common ones are in products. You have the UPC code. That's just down near it's with the barcode that you see on just about every product that's sold. Another common place you see identification numbers are ISBNs. Those are on books and papers that are books and magazines that are published. And another case is on automobiles. You have VIN numbers, they're called VIN, vehicle identification numbers. And a final example is banks have routing numbers, and they also have numbers that correspond to specific accounts. But the routing numbers are to identify a certain bank. So these are all identification numbers, and every identification number has a main part that carries the information about the number, about the product. So the UPC code, the main part would tell you the manufacturer and what the product is. The ISBN would tell you the company or the country in which the book is published, and the author and the title and so forth. So each of these numbers carries information in what's called the main part, and then the last digit is called a check digit. Now, what we'll do is start with an example. And there's a book. The title of the book is Do Princesses Wear Hiking Boots? And this is a book that I saw in my granddaughter's room today, and I copied down the ISBN number, and it was 08735882882. Now, like I said, the first part of this number is called the main part, and that carries the information about the book. And this last digit is called the check digit, and that's what this lesson is about, because check digits are calculated using mod arithmetic. And if right now you're probably in 1107 studying mod arithmetic. So this is one of the topics in that chapter, is check digits. So I'll show you an example of how the ISBN is calculated, and then we'll talk more about the formula. But there's a general form here, that every calculation of a check digit is going to start by doing a calculation on the main part, and then doing a mod arithmetic, and then that gives you the check digit. So the main part I'm just going to write down, and you can write this horizontally as the book does, or you can write it vertically. And so I'm going to write it vertically. This is my number, 087358828. Now that's the main part of the number, and so next to the main part, what you're going to do is multiply each digit in the main part by a multiplier, and so I'll just copy my multiplier down next. Now for all ISBN numbers, the multiplier will be the same. And then when we switch to UPC codes, it'll have a different set of multipliers, but you'll have the same general form. So for ISBN numbers, the multiplier is particularly easy to remember. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is for the main part of the ISBN. So these are just your multipliers. I'll just put multiplier here. And this is the main part of the ISBN number. Now, they call this a multiplier because we're going to multiply. And so you multiply 1 times 0, you get 0. 2 times 8, you get 16. 3 times 7 is 21, and so forth down the line. 12, 25, 48, 56, 16, 72. Now, after you do the multiplication, then you add these up, and you get a total of 266. Now, here's where the mod arithmetic comes in. The check digit is found by taking this total that we have, 266, mod 11. Now, again, different types of identification numbers will use different mods, but for ISBN, they're using the mod 11. And when you do the mod 11 on this, you'll get 2. Now notice that 2, now by the way, if you had if you don't know how to do 266 mod 11 to get 2, basically what this is if you were taking the biggest multiple of 11 that you could away from 66, 264 is a multiple of 11, and if you subtract 264 from 266, you get 2. Now, if you're a little shaky on the mod arithmetic, there's another tutorial on just mod arithmetic calculations. You may want to see that if you have trouble seeing how to get the 2. Now, so the check digit is 2, and when we look back up at the original number, there it is. Check digit is 2. So that's how you calculate a check digit, and the general approach is just like this example, except for different identification numbers you'll have different multipliers and a different mod calculation. Now, the general formula, the way it's written in the book for ISBN numbers is this. They write 1 times A9 plus 2 times A sub 8 plus 3 times A sub 7, and so forth down the line. So 4 times A6 plus 5 times A5 plus 6 times A4 plus 7 times A3 plus 8 times A2 plus 9 times A1, and you take that whole quantity and you do a mod 11. And when you do that, you'll have a 0, which is the check digit. So in this book, they always denote the check digit by A0, and the digit just to the left is A1, and just to the left of that is A2, and so forth down the line. So A sub 9 is the first digit on the left-hand side. So, for example, in our book about the princess and hiking boots, the first digit on the left is 0, and that would be A9. So A9 would be 0, A8 would be 8, A7 would be 7, and that's just a coincidence. A6 would be 3, A5 would be 5, if we write down the main part again. So just to make a matchup with what you see above, there's the main part digits: 0, 8, 7, 3, 5, 8, 2, or 8, 8, 2, 8. So those are the digits that we had above. Now, the formula, you need to be able to see how to read this formula, because when you have tests and quizzes, you'll probably be given these formulas written in the form that the book writes them. Now, you also should realize that if you go on the internet and you look up formulas for check digits, another author may just decide to call A1 the first digit on the left instead of A9, and so all of these subscripts are reversed. Now, the point is that the A's are just the digits of the main part, and that's really all you need to remember. The subscripts, what the subscript is really not used. You just write down the main part in sequential order, and you'll fill in the right values. So that's the way the formula is written. Now, that's ISBN numbers. So now we'll move on and look at bank routing numbers. Now, just to practice with our formulas, the bank routing formula is this. The check digit is 7 times A8. And that's the first digit on the left, remember? And then it goes 7, 3, so it would be 3 times A7 plus 7, 3, 9, 9 times A6 plus, and now it goes again, 7, 3, 9. So it would be 7 times A5 plus 3 times A4 plus 9 times A3 plus, and then it starts again, 7 times A2 plus 3 times A1. But now A1 is right before the check digit, so that's where we're done. So we take that whole quantity, and this time, instead of doing mod 11, they're going to do mod 10. So this is the bank routing number, check digit. So that's another formula. Now again, I'll do an example. As an example, suppose that we have the main part of a bank routing number is 0, 6, 1, 2, 1, 1, 3, 0. Now, that's the main part of the number. And the question is, or the problem is, to calculate the check digit. Okay. Now, to do this, you can plug these numbers into the formula, 0 in for A8 and 6 in for A7 and so forth, and you can write it horizontally. Or, to do the same thing vertically, I'll write down my code, 7, 3, 9, 7, 3, 9, 7, 3, and then write down the main part of the number, 0, 6, 1, 2, 1, 1, 3, 0. Now, if you write it down like that, we just need to multiply and add. So we'd have 0, 18, 9, 7 times 2 is 14, 3 times 1 is 3, 9 times 1 is 9, 7 times 3 is 21, 3 times 0 is 0. So the total, when you add these up, the total will be 74. And then, to finish calculating the check digit then, the check digit will just be 74 mod 10. Now again, the mod arithmetic calculations you've already learned, but there's a shortcut for mod 10 that doesn't work for other mods. But for mod 10, the shortcut is that the mod value is the last digit, at least for the positive numbers. So this is 74 mod 10, and so that would just be 4. So the check digit in this case is 4. So that means that the entire number, the bank routing number, would be 06121130. That's the main part, and then 4 for the check digit. So that is the bank routing number. Now, we'll continue on with some more examples of this. As a continuation of this example, the bank routing number that we just talked about was 0612113004. And remember, the 4 is the check digit. So, this is the bank routing number that we were doing. Now, suppose that when this routing number is read, suppose that the 1 and 2 were interchanged or transposed. So suppose it was misread as 06, instead of 1 2, 2 1, 1 1, 06. Oh, sorry. Let's start over. Suppose the 1 2 is read as a 2 1. So the number would be read as 0 6, and now instead of 1 2, 2 1, and then it would continue with 1 1 3 0 4. Now, if the number were read that way, the question is, would this error be caught? Would the transposition error be caught? Now, to check to see if it would be caught, what we need to do is calculate the check digit that would come from the main part of our misread number. And if that check digit turns out to be 4, as it did with the correct reading, then the error would not be caught. However, if the check digit turns out to be something other than 4, the error would be caught. Now, let's go through the calculations again. So I'll write down the main part as I've read it. 0 6 2 1 1 1 3 0. Now notice I'm not copying the check digit. I'm just going to, that's not part of the calculation. So I'm going to calculate the check digit and see if the error is caught. So the multipliers again for the bank are 739 739 73. So when I do the arithmetic, I'll have 0 18 18, 7 times 1 is 7, 7 times 3 is 3, 1 times 9 is 9, 7 times 3 is 21, 0 times 3 is 0. And then I find the total. And the total is 76 this time. And then if I do 76 mod 10, I'll get 6. So this would be the check digit for the misread number. So, is it the same as the check digit for the correctly read number? The answer is no. So since 6 is different from the true check digit, we can say that the error was caught. So that's the kind of thing that you can, that's the reason check digits exist. So if errors are made, the errors will be caught. And it turns out that these check digit formulas will not catch all errors. And it would be nice if they would, but they won't. For example, and I'll give you this as a homework problem. Suppose you had interchanged the 6-1 and wrote it as a 1-6 in that same example. If you check this out, you'll find that that error would not have been caught. It was still a transposition, but transposing the 6-1 instead of the 1-2 would not get caught. So check it out and see to practice on this. Now, the next example I'll do is still going to be on bank numbers. And suppose that a bank routing number is written as 025500, and then there's a pound sign and a 1 and a 6. Now, the pound sign is indicating a digit that can't be read, illegible digit. The scanner or the person who's trying to read this can't make out what that number was. It got smudged, it got misscanned. We don't know what it is. But we do know it's a bank routing number. And so we do know this 6 is the check digit. And so the problem is to try to figure out what this missing number is. So, to start off, the approach would be, well, let's calculate what the check digit should be, and then see what missing number would make that be a 6, the check digit be a 6. So to calculate the check digit, we're going to go back and use the usual bank formula is 739739773. And then I copy down the digits that I can see is 0, 2, 5, 5, 0, 0, the digit, missing digit, and then the 1. So when I do my multiplication, 0 times anything is 0, so I get 0, 6, 45, 35, 0, 0, 7 times the pound sign, and that just stands for a missing digit. I don't know what that is yet. And then 3 times 1 is 3. So when I total this, I can total everything except the 7 times the pound sign. I just have to leave that separate. So when I total this, I'll get 7 times the pound sign plus 89. So all the numbers I can add up in that column add up to 89. And so I'll come up here and say, well, I know that if I take 7 times something plus 89, and then I have to do a mod 10 on that, and I need to get a 6. Okay? So, now, one of the properties of mod arithmetic is that when you're doing multiplications and additions, any number can be replaced by its mod value. So the 7 times pound sign, I can't change that because I don't know what the pound sign is. But the 89, I can replace that by a 9. They call that 89. They say that 89 is congruent to 9. That is, it has the same mod value as 89 and 9 have the same mod value, and that mod value is 9. So I can replace that and say 7 times the pound sign plus 9 has got to give me 6. And this is in mod 10 arithmetic. So it looks like an equation to solve, and you actually can treat it like an equation to solve if you do the mod arithmetic carefully. But rather than do that, we'll just use the other approach to solving equations, is that you can do the calculations for each of the possible answers. Now, you couldn't do this in algebra very often because there are infinitely many values the pound sign can have. But when you're talking about digits, they've got to be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. And so we can just check it out. So I'm going to use trial and error. And I'll try 7 times 0 plus 9. And that would give me 9, which is not equal to 6. So that didn't work. And then I can try 7 times 1 plus 9, which gives me 16. And 16 in mod 10 is 6. And so we were lucky that we found the answer in actually the second step here. So this is the missing digit. Okay, we'll go to one more example and talk about the UPC digit. The formula for UPC code is that the check digit, A0, is the negative of the whole quantity. And inside the quantity you'll see 3 times the first digit on the left, plus 1 times the second digit, plus 3 times the third digit, plus 1 times the fourth digit, plus 3 times the fifth digit, etc. All the way down until you get to the very next digit before the check digit. The last digit just before the check digit at the end is 3 times A1. So that's the formula that you'll see. Now the thing that's different here that you haven't seen in the other formulas is that they have a negative in front of this. And so we have to do all the calculation in the parentheses, and then it's the negative of that number mod 10. And so let's do an example. This is, I went into my cabinet and I pulled out a bag of Sun Chips, and here is the UPC for the Sun Chips. It's 0, 2, 8, 4, 0, 0, and then 0, 4, 3, 6, 2. And that's the 11 digits in the main part. And then the last digit is a 2, which is the check digit. Now, my question in this example, is this a correct UPC number? So in other words, did I copy this number correctly, or did I accidentally or intentionally make an error in the writing of this number? So in other words, is this a valid UPC number? So we're going to apply our formula, and again, if you look up at the code, if you write it vertically, you'd have 3, 1, 3, 1, 3, 1, 3, 1. Let's see, that's 2, 4, 6, 8. 313. So those are the 11 digits. And now I'll write down the digits in my main part of the Sun Chips number. So I have 0, 2, 8, 4, 0, 0, 0, 4, 3, 6, 2. Now the last 2 you see up there on the number that I wrote is supposed to be the check digit. So we know what the check digit's supposed to be, and so if we calculate it and if we get 2, then that means it's a correct number, or at least it's most likely to be a correct number, because probably if there had been an error it would have been caught. Or if it's not a 2 when we do the calculations, then it means that I either purposefully or accidentally put an error into the UPC number. So let's check it out. And again, you first multiply, you get 0. 2 times 1 is 2. 3 times 8 is 24. 4, 0, 0, 0, 4, 9, 6, 6. So I need to total this up. Okay, the total is 55. Now here's the little switcheroo. It has to be negative 55 mod 10 should be the check digit. Now again, I'm going to refer you back to the tutorial on mod arithmetic, but to find the mod value for negative 55, one of the basic rules in mod arithmetic, or one of the conclusions in mod arithmetic that you can use, is that if you add multiples of 10, it won't change the mod value. So if I add 10 to this, it wouldn't change it. If I added 20, if I added 30, if I added 40, none of those multiples of 10 would change the mod value. Think of some positive numbers, like 13 mod 10 is 3, and if you add 10 you get 23, and that's still 3, and 10 more makes 33, still 3. So that's the idea behind this. But in other words, to find the mod value for a negative number, one technique would be to add enough multiples of 10 to make a positive number. So I'm going to say negative 55 plus, now how many multiples of 10? If I added 60, that would make it positive. So I'll do that. So negative 55 plus 60 mod 10. And that'll be the same value because I added multiples of the modulus. So that would be 5 in mod 10 arithmetic. And 5 in mod 10 arithmetic would just be 5. So the check digit for the number that I've written, check digit for this number is 5. However, the check digit is supposed to be 2. And you can see that by looking at the 2 up here. Supposed to be 2. And since it's not, there is an error, most likely, in the main part of the number. Now I'll confess that this was a planted error, and actually that 4, the 4 in the main part of the number toward the end there, the 4362, that 4 should have been 7. But there's no way to have known that. All the check digit tells you is that there is some kind of error, most likely. So hope this has helped. You may want to review the mod arithmetic and then do some homework in the section on check digits.